video we'll talk about designing code using flow diagrams. Up until this point we've really worked on pretty straightforward problems. They might have had the odd condition here or there, but most of it we could probably do just in our head in terms of designing the code. But in the real world, we're generally trying to solve problems that aren't so simple. There might be a whole bunch of different conditions that we need to meet, multiple sensors, multiple different outputs, and they all need to work correctly together. And we need to verify that they're working. So what we need to do is start designing code rather than just hacking together a few lines of code and hoping that works, because normally it won't, and then we'll have to go back and try and fix it and work out what our problem was. Well, in this video we'll be looking at one technique that's often used called flow diagrams. And flow diagrams are used to allow us to break down complex problems into a series of simple steps, and we can ensure all those steps are correct diagrammatically. Now, once we've created our flow diagram, it makes it really easy for us to write our code and then verify our code and verify that that code meets the specification we've designed. It also removes all the tricky syntax and things like that and concentrates not on the syntax or how we write the code, but on the behavior of the code, what it's meant to do. And that can help us verify that we're doing what we're expecting to do. We're doing what we've designed it to do. So flow diagrams are a good way to design code on paper and speed up the actual implementation and testing of our code when we go to actually program it and implement it. There's other techniques like pseudocode, for example, but we're going to be concentrating on flow diagrams. When creating flow diagrams, we've got three different symbols that we need to learn. We have an oval, which indicates the start or end of the particular behavior. Now, the code obviously needs to start somewhere, and most of the code that we're working on doesn't have an end. The end is actually when we physically remove the power from the device or turn it off. We have a square, which indicates some sort of processing step. It might be a computation, reading switch values, setting pin output voltages, something like that. And we have logical decisions, which are diamonds. These are logical decisions that need to be made, like if statements or while statements, where we're comparing one thing with another and doing something based on the output. Let's look at through a really simple example that uses all three of these elements. Essentially, we've got a switch that we're controlling the LED. If the switch is pressed, we'll put the LED on. If the switch isn't pressed, we'll put the LED off. Now, pretty simple example, and the sort of stuff we've been doing for a few weeks now. You see at the start, we have our start condition, and we're setting up our pins there. So we need to set up some of our pins as inputs and some of our pins as outputs. We have our diamond condition there, where we check if the button's pressed, and you'll notice there's no complex syntax here of whether it's low or high or anything like that. All we're simply doing is writing it in a nice English form, which is very easy for us to verify later on. And then we have our different conditions: set LED on, set LED off, and so on. Now when we've come up with that, it's pretty easy for us to transfer that directly into code. We'll be showing how that's done in a slightly more complex example. Let's go through that more complex example now. We're going to solve this particular problem. We're going to create a flow diagram and use that flow diagram to write our code. So we have a circuit that has the following: an LED on pin 10, two switches, one on pin 6 and one on pin 7, and an analog input on pin 2. And the behavior needs to be as follows. If switch 1 is pressed, the LED should be at 50% brightness. If switch 1 isn't pressed and switch 2 isn't pressed, the LED should be at 95% brightness. Otherwise, if none of these conditions are met, what we need to do is read the analog input, divide it by 100, and then we supply this result as the LED brightness. You notice there's a few different conditions here, a few different things that we need to work with. Still not overly complex, but let's go ahead and see how we can implement this, first with a flow diagram and then with our code. Okay, let's draw the flow diagram for this now. Well, flow diagrams, we need to start somewhere. So we always have our start condition, which is essentially when the microcontroller is turned on or the reset button on the Arduino has been pressed. From there we need to set up our inputs and outputs. So we'll first set up our switches as inputs, and then we can sub our LED as an output. We then have our first conditional statement. We need to check the value or the voltage at switch 1. So is switch 1 pressed? And we have our two conditions, no and yes. Let's follow the yes condition first because that one's rather quick. We're told if switch 1's pressed, the brightness for the LED should be 50%. So that one was very easy. Then we'll check if switch 1 is not pressed. If it's not pressed, then we need to check switch 2 and do something based if that's pressed or not. So we do the same thing. Is switch 2 pressed? Now if we say switch 2's not pressed, well then the LED is 95% bright according to our brief. Okay, then we have our condition where neither switch 1 then we have our condition where neither of these were true. So switch 1 is not pressed, but switch 2 is pressed. In this case, we need to read the analog input, divide it by 100, and supply that value to the LED brightness. So let's say we'll have a variable called A, and that can be where we read the analog input. So A equals read so A is read the analog value, A is equal to A divided by 100. And then we supply that value as the LED brightness. And so we supply that value as the LED brightness. And then we go back to the start and do it all again. So all of these will go back to this point up here. We don't need to set up the whole inputs and outputs again. And everything goes back around. So there's our flow diagram. Now if we want to check our behavior against the specifications, against what we've been told, we can quickly follow each of these conditions through and say, is a switch pressed, yes or no, is a switch pressed, yes or no, and see the behavior and make sure our design meets the specifications that we've been told to make. Now let's go ahead and write some code. Now when I write code, regardless of whether it's transferring a flow diagram into code or just writing code as it is, I like to start by writing comments. Comments are a nice English description of what's being done and help us to verify that we're doing what we're expecting. And we can leave them in there because the compiler ignores them. And they're a bit of a signpost for other people to tell them how we've actually gone about solving the problem. So let's go about writing some comments. So comments always start with a double forward slash at the start of them and then continue to the rest of the line. So we need some comments to set various parts up, like give pins names, because we've got our LED and we've got our switches and we've got our analog input as well. So we'll define those there. We then need our setup function. So we'll have some comments that relate to our flow diagram. So set switches as inputs and set LED as output. And then we'll have our loop function. And so we can have our comments is switch 1 pressed. If this is true, LED is 50% bright. If it's false, well then we need to check switch 2. Is switch 2 pressed? Now if this is true, we can say read analog input, divide input by 100, supply input to brightness. If it's false, LED 95% brightness. Now we'll put a true back here. Okay, so you see we've basically put that in what we call pseudocode, commented code that doesn't actually get read by the compiler but describes the precise behavior that we're looking for. Now we can go back and fill in the actual code pretty easily. So let's give these things some names and some assignments. So we'll start with our LED. Int LED equals 10 because it's on pin 10. Int switch 1 equals 6. Pin 6. Int switch 2 equals 7. It's on pin 7. And int analog input equals 2 because it's on pin 2. So all our pins now have names associated with them. Then we need to set them up. So we'll set up our switches. So we use the pin mode function. And our switches are inputs. And one thing I'll remember earlier on is that if we're using analog outputs, which we'll be using to drive the LEDs, we don't actually need to set them up. All that's set up as we write them. It's the same with our analog inputs. We don't need to set those up at all. When we use the analog read or write function, they're automatically set up for us. So we can remove that comment there because we won't be doing it. Now we've got some conditions that we need to do in our loop statement. Is switch 1 pressed? That sounds a lot like an if statement to me. So we can write it. If low is equal to digital read switch 1, we want to do something. Now you'll notice it's low because that's pressed. That's something that we need to interpret because when we press the button that brings us down to a low voltage. And if we just follow our lines of code, we can pretty easily work out where our brackets need to go. So this is the part that's true, Then we have a part that's false, so we say else, and that covers the whole rest of it. And then we have another if statement inside here. So if low is equal to digital read switch 2, we've got a part of that that's true, and then we've got a part of that that's false. Okay, now let's fill in our actual conditions. So if this one happens to be true, we perform an analog write. We're putting it to LED, and we know that it's 50% brightness, and the number that we can supply is between 0 and 255. So 50% of that is 127. So we've got 50% brightness on the LED there. Is our second switch pressed? Well, if our second switch is pressed but our first switch isn't pressed, we follow these lines of code and we read our analog input. Now it'd be useful to have a variable that we can store this analog input at. So we should declare that one up the top. Int analog input value. So we've stored it at the top. We'll write it down here. And it was called analog input, that particular pin. So we've read it. We then need to divide it by 100. There's a nice little shortcut what we can do instead of writing that. We can actually say that's shorthand for saying analog input value divided by 100. Analog input value divided equals 100. It'll do exactly the same thing. And we need to supply that input to the brightness. So we say analog write okay, and our last one, we need to do the analog write to our LED, and we need 95% brightness. Now remember, it's 0 to 255 and it needs to be on 90% of the time, which means that we actually need to have a low value 95% of the time, high value 5% of the time. So easiest way to do it would be to say 0.05 or 5% of the time high times 255 13. So we supply 13 in here and we're done. Now the code's a little bit messy because it's got a whole lot of comments in there. We could clean them up a bit if we wanted, particularly some of the more obvious ones like whether it's true or false, because that's really controlled by our brackets. But there we go, we've gone through and solved the problem, and if we did have any problems we could very easily quickly compare them back to our flow diagram and say, well, did they actually match the flow diagram? And we can work out, was our flow diagram wrong? And it probably wouldn't be, because that captures the behavior in a nice way. Or have we written some code that doesn't quite reflect what we're expecting it to do? And I'll show you one last little trick which makes your code look a bit neater. If you go to Tools and click Auto Format, or alternately Control T, what that will do is it will indent everything nicely for you. It makes your code a whole lot more readable. So you'll notice whenever you have an if statement, whatever's inside the if statement is indented. When you have an if statement inside an if statement, that's indented the second time, so it makes your code nice and readable.